So, Professor Holton, what did Einstein did so well 100 years ago that we're still celebrating his work?
Well, we are in the anniversary months of his revealing what general relativity can do. He had been working on it for 8 years, and it came to him in the last week of his November period, when he finally knew that he had reached it, and it almost frightened him because of the implications that he had managed to put together space-time and gravity in a way which is completely unique and amazing in terms of the way a human being can make a statement of that sort. And he has become an icon because of it, since after all it was then, a few years later, proven to be true in experiments. So we are celebrating this as an accomplishment beyond most others. One thinks of Darwin and Freud and Copernicus and Galileo as being similar in their influence on their science.
Would you be able to, I remember this line from Einstein saying that one should be able to explain it to his or her grandmother. Would you be able to try and explain that to me, at least, that I'm no physicist?
Well, it wouldn't be easy without a blackboard, but I think there is a way of doing it. By focusing on a work I discovered when I was asked to be an archive, to put together the archive at the Einstein area in Princeton after he died. And I found a unpublished manuscript of 1920 in which he said that in 1907, when he was still at the patent office, sitting on a chair, he had what he then called the happiest thought of my life. A very remarkable thing in German, der glücklichste Gedanken meines Lebens. Well, if a man like that says this, and he didn't say it about other things because he didn't suddenly find things, but here he had one thought, and this thought is very amusing as well as profound. He said, if I were not just sitting on a chair, but if I were on my house roof and I slipped and I fell down, accelerating through gravity, then not bothering about what happened to me, I might take out some keys or other things from my pocket, let them fall, they go together with me. That means that in a way we are in an inertial system, because at rest. Although we are accelerating, we can also say this is a system at rest. Therefore, gravity, which pulls us down, and acceleration, which I'm experiencing, must be the same thing. This was the key for general relativity, that acceleration and gravity. Now, acceleration comes from mechanics, and gravity, of course, from Newton, and they too had not been put together in special relativity. But in 1907, thanks to this glückliche Gedanken, he was able to put those two things together. And it can be explained in beautiful ways, but it takes pictures, it takes drawings, it takes a little mathematics on the blackboard. But the key to it all was that happy thought, which for an ordinary mortal is a little remarkable that somebody doesn't think of dying at the end of it all, but he was thinking about what it was like while he was falling.
Has it stood the test of time in these 100 years? So is relativity still up?
Yes.
And being accepted and being strong among the community?
You're completely right that It was really a very theoretical kind of thing, untested when it was published, just amazingly beautiful. So it was really a theoretical, beautiful statement, and much admired at the time, but it hadn't been tested, although it gave one answer to a puzzle, namely the precession of the perihelion of Mercury. Mm-hmm. That much was in it, but nothing very much else was being promised. Mm-hmm. There were possibilities, for example, because light having energy and mass being equal, it would be attracted to move toward a gravitating body like the sun, mm-hmm. if the light was nearby. Therefore, it would be deflected. That was one prediction. Mm-hmm. And it was, in 1919, found to be true. And he became very famous as a result. And there were several similar experiments, all of them in astronomy. Until 1969, there was then a proof that it also can be shown in a laboratory, inside an earthbound building. Mm-hmm. That was done actually in the laboratory in which I have my office by one of my colleagues, R.V. Pound. R.V. Pound and one of his students did the following. They put an emitter of gamma rays at the bottom of the building, and 70 feet above it, near the roof, it's about 22.5 meters, they had a receiver, and then they switched the two. And they showed that the gamma ray, which is a photon, which has mass as well as energy equally, was being acted on by the gravitational field. Mm-hmm. And this was therefore precisely predicted by general relativity, even though in that short distance, unlike the astronomical ones, in that short distance, you had to make an experiment, which they did, which was so fine-tuned that the result was of the order of 1,000 trillionths of a part. 10 to the minus 15, so to speak. And they did, in fact, show that this works not just astronomically, it works here. One result of all of this is that general relativity now is in our pockets and in our cars because of the gravitation, the global positioning system, which depends on relativistic corrections between the satellites and the receivers. Very, very, very fascinating, unbelievable to predict in 1915, but nowadays we have general relativity in our pockets.
I was wondering about two I guess interesting points in the decades after the formulation of general relativity, which are, on the one hand, the detection of the cosmic background radiation, which was let me put it this way, a big hit. That was a big yes. Amazing positively for relativity. And then we just recently had this almost second hit, which was the gravitational waves that we didn't quite get this time. What do you make of these two moments in history?
There is a wonderful research area which is being pursued by a number of people to see whether the background radiation has within it a signal showing that gravitational waves will exist. And a couple of my colleagues are working on that. Very difficult circumstances because it takes a great deal of absence of noise, so to speak, in order to get a message that is so complex and tiny. So there is work here of the kind that is precisely what most scientists love, namely, it is a big question, the answer to which would be yet another confirmation of a very complex theory. Mm-hmm. Because in Einstein's work, gravitational waves were expected. but they have not been found despite a lot of work on it so far. But nobody has, until recently, really looked at the cosmic, the background radiation. It was done in a terrestrial way with laboratories. So this is going to be the new way of looking for gravitational waves.
Let me get back to Einstein's thinking, and something you wrote elsewhere that I think you called the Ionian enchantment.
Yes.
This fixation that, I don't know whether it must be true, but there is a fixation, and Einstein's work is obviously there, with the need for coherence, beauty, simplicity. Would you elaborate on that?
Yes. Well, in 1955, when he died, I was asked to talk about the history of relativity theory. And I looked around, and there was nothing in the publications. And so, by some luck, I was allowed to come to Princeton to look at Einstein's manuscripts and letters and the whole exchange of letters as some 40,000 documents. And for 2 years, his secretary, who still was there, and myself and some graduate students I hired for it, went through his whole set of archival material and put it into order so that scholars could work on it. That was one of my aims in it. But in the doing of it, I had to read some of it, or most of it, over the years. And it became clear to me that here was a mind at work which had looked at nature through a particular set of spectacles, of eyeglasses. Namely, the most important thing is unification. From childhood on, he looked for this. This first paper, published paper, was on capillarity, a very boring subject. But to him, very exciting, because liquids in a large straw go down, but in a thin straw go up. So he says, there are two things opposite. They have to be the same. So he looked for molecular forces that would explain both the up and the down in the two different conditions. Very typical of him throughout his work, seeing some commonality among things which to other scientists were opposites, bringing them together instead of having different theories. His relativity paper of 1905, for example, starts with saying, if you take a magnet stationary and a coil that moves to it, you get the current in the coil. If you then have a stationary coil and a moving magnet, you get the same kind of current, but you have to understand it to different theories, different equations. To him, at the very first paragraph, he says, two things look unlike, but they must be the same. Mm-hmm. So special relativity was built on that, shall we say, enchantment, that for no particular reason, being captured by this theme, that I call it themata, the theme that unification is the answer to difficult questions. But then, in addition, I found, by reading his stuff, that parsimony is another important idea. Namely, there should be, like in Newton's work, there should be as little as possible. In Newton's work, he starts with 3 proposals, F is ma and so on. And out of these fashions the whole solar system working. So he again says very little has to be done with a lot. And he does that throughout. His papers are very condensed. And so he works through these and many other such themata, about 7 of them which I identified.
Now you're leading me to think about his creativity and the Gedanken experiment and how this was even picked up in popular culture, the idea of making these experiments, coming up with seemingly outrageous setups and testing, and this correspondence with the quantum field and the relativity field. Do you have an idea how he got to be, if he did, such an original thinker? Because he seemed to think in a different way.
Yes. Well, he once was asked what accounts for his success, and he gave a funny answer, saying, God just gave me two things. I was always neugierig in German, which means urging for the news in a passionate way, passionately after anything that's new in science. That's one thing. And the other one, obstinacy, like a mule, that I was going to stick with that, as he did with relativity. He actually started with the thinking of relativity in 1899. We have that in a love letter he wrote to his girlfriend, Mileva, in which he says, I just read Heinrich Hertz on electrodynamics, and he talks about the ether. I smell out that this is a word, it's not an actual fact. He already had this instinct of what is right, what is wrong, where does it lead him. So from 1899 on, he worked on relativity and then made it flourish in the final work of 1915. Took all of that time for him to really work it out. And that is traditional. The story that I told you about my happiest thought of my life is the only time when something seemed to fall into his head suddenly. Mm-hmm. Everything else he had to work out painfully and long period. That one moment is very much like Mozart. Mozart was once asked by his mother, how do you get all these melodies? And he says, well, mother, I happened to sit in a carriage between one town and another, and es ist mir eingefallen. It fell into my head. The whole symphony fell into his head. It's very similar to this glückliche Gedanke. You're completely right, Duncan, of Einstein. It happens to a few people that they have an instinct that leads them to a very profound new idea.
But what were his influences? He's of course a product of his, I guess, society, family, wife, colleagues. What were his main influences, would you say?
Well, it starts very early. I once asked Erik Erikson, the psychologist, can he give me an explanation for Einstein coming, what he became? Because he is a child psychologist, he should perhaps have an idea. So Erikson, who is a very great person and was a friend of mine, actually went down to Princeton and talked with the secretary who had been with Einstein since 1928 till 1955 and asked her, are there some hints that she picked up during all this time? And she said yes. It was his mother. Because Einstein was a very difficult child. He didn't want to speak until about the age of 3, until, as Erik Erikson says, until he had something to say in a sentence. He therefore was perhaps looked at in a dubious way early. But his mother discovered that there is a way into his soul through music. And she being a pianist, and he took up the violin. And between the two of them, there was a relationship formed by music. And so his mother was the first great influence on him. Then came a second one, which is very fascinatingly similar to what happened to other scientists. In his case, the family opened itself up once a week to a hungry student who doesn't have much money to share the meal, a man called Talmy, who became a doctor. And Talmy talked to this child, he was 10, 12, 13, and discovered what his parents and teachers did not know, namely that he has a very interesting mind. So he gave him the Euclid book, which Einstein later says was a holy book for him. He gave him Kant to read. He discovered this child. So Talmy became a lifelong friend, and they corresponded a lot afterwards. So that kind of an influence. And then through his reading, von Humboldt, reading Mach, as I said before, he was a self-trained kind of a person. He loved to understand things on his own way. For example, in electrodynamics, it was not taught in his school. He had to find it out by taking people's books and studying them himself. So in a way, he was also very influential on himself as an autodidact and a person who could, through his passion for something new, go into new fields and flourish in them.
We were talking about the influences that made up Einstein. Yes. And I was wondering from a sort of a Marxist historical perspective, what made him or somebody in his place possible at that time? The political and cultural influences that sort of set up the grounds for him to blossom?
Well, there are various answers to that at the different stages. For example, he hated his high school because it was so militaristic, and he dropped out and asked his parents to take him out of citizenship even, not to make him a German citizen, and went to Switzerland. And there he failed in the entrance examination in Zurich. And a very good man saw that there's much promise in him nevertheless, and said, what you need is another year or so of high school. You dropped out at 15 and a half, you haven't had enough. You're too early. Go to the high school. There's a good one in Aarau, not far away. Einstein went there, and it was important for his whole career, because it was run on the ideas of a Swiss called Pestalozzi, who said, for difficult children particularly, it's very important not to make them do the ABC and the 1, 2, 3 all the time, but to also bring them visualizable material, put them out into nature, give them something to play with, and so on. Get the more playful part of childhood into their life. This was exactly what Einstein needed, because he, as he said later, he had great trouble thinking in terms of words. And even in terms of mathematics, he needed help for that from his friend Marcel Grossmann. But he had a wonderful way of visualizing. To him, as he said in one of his publications, words come to me with great difficulty, but I think in terms of like a jigsaw puzzle, trying to fit together shapes in my mind. They stand for the ideas in theory. So his visualization, like falling from the roof, these Gedanken experiments allowed him to visualize an experiment that couldn't be done yet, and shouldn't be done perhaps, but which to him were the key to understanding something.
Would you say that if Einstein would have been born 20 years prior to his date, would have been that successful, or could have come up with the idea of relativity equally 20 years before?
Well, Einstein, for his special relativity, didn't need anything other than 19th century work. The research of Fresnel and of Faraday. And relativity is based on that, not on some experiment that was crucial to him, but rather things which had been lying around as puzzles that had been worked on by people long before him.
Is he also the top scientist in the history of science, would you say?
Well, he is along with a Galileo, whom he admired, or Newton, or Maxwell. He regarded himself as doing a type of work that Maxwell would do. And he had a picture of Newton and Maxwell and Faraday in his house, the only 3 big pictures of scientists. So he adored them, and he knew that he was really following in their trail. And so we can say he's of that area of developing thinking which gets that high, that it shows how high humanity can go in its imagination.